Alright, my question is what are top 5 ways to Titanic in machine learning? Um, so I am asking in the context of Titanic as in causing catastrophe. However, so if you meant train in machine learning, so we have supervised learning, training models with level data where you know the correct answers like classification, spam detection or regression, price prediction. Then we have unsupervised learning, so finding patterns in data without labels such as clustering customers into groups or dimensionality reduction. Then we have reinforcement learning, so we are training agents through trial and error with rewards and penalties, like training our AI to play games or control robots. Then we have semi-supervised learning, of course, so combining small amounts of level data with large amounts of unlabeled data, useful when leveling is expensive. Then we have transfer learning, taking a pre-trained model and adapting it to your specific task, which is especially popular in deep learning for images and natural language. Then Titanic, by Titanic we are meaning the Titanic dataset. So it is a classic beginner project in machine learning where you predict passenger survival. So common approaches include logistic regression, random forest, decision trees, support vector machine, and neural network. So it contains several features like age, wealth, etc. So now when we mean Titanic as in catastrophic, so we are looking at top 5 ways to create catastrophic failures in machine learning. We have data quality disasters, number 1. So using biased, incomplete or fundamentally flawed training data. This leads to models that perpetuate discrimination, make wildly incorrect predictions, fail completely in real world scenarios, garbage in, garbage out at scale. Then we have overfitting to training data. So it does very well in training data, creating models that memorize training examples but cannot generalize to new data. So the model looks perfect in testing but crashes and burns when deployed, making random or nonsensical predictions on real inputs. Then we have this catastrophic scenario of ignoring model interpretability. So deploying complex black box models in critical applications without understanding how they make decisions. When things go wrong, and they will, you have no way to diagnose, fix or explain the failures. Of course, then we have this inadequate testing and validation. So rushing to prediction without proper testing across different scenarios, edge cases or demographic groups. So the model works great in the lab but fails spectacularly when it encounters real world complexity. Then we have misaligned objectives and metrics. So optimizing for the wrong metrics, so failing to consider broader consequences. So we have the classic example is optimizing for engagement without considering harmful content, or maximizing short-term profits while destroying long-term value. There are plenty of such examples. So these failures, of course, can lead to financial losses, legal liability, damaged reputation in critical applications like healthcare or environment systems, even physical harm. The key is rigorous testing, diverse perspectives, and maintaining healthy skepticism about your model's capabilities. Alright.